Thanks, everybody. Welcome to Change Notice. This is a weekly video podcast for the Build Better community. This is your first time joining us. Here's the format. We do 20 to 30 minutes of interviews with our guests. Today we have Remi, which will be recorded for future posting, followed by 20 to 30 minutes of off-the-record discussion that you can only hear if you join us live. This week's guest is Remi Duquette, VP of Innovation and Industrial AI at Maya HTT. Maya HTT is an engineering solutions provider that delivers advanced services and products to businesses in the engineering and data center industries. So maybe as a starting point, Remi, tell us a little bit about what Maya does. So make sure everyone in the audience knows. And tell us a little bit about what you specifically are working on at Maya.
Certainly. Well, thank you first, Anna, to invite me today. It's a pleasure to always chat with you. And in terms of Maya, we've been a long-term software developer company. We've established ourselves as a simulation software company for the last 30 plus years. We started in space, literally doing heat transfer simulation of spacecraft in orbit, that kind of stuff. And we evolved slowly into more the design manufacturing aspects of the simulation portfolio. And then now in the last decade into operations and real-time telemetry treatment for AI type purposes. And that's really my main focus at Maya. I've been with the company 20 years now. And I oversee all the industrial AI tribulations that we've gone through in the last decade. So yeah, from simulation all the way to real-time operation, but with a very industrial engineering manufacturing focus is really our DNA.
Got it. So, you've served thousands of customers worldwide. What have you seen over the last decade that's different from before? From whether that's engineering, design, or manufacturing? How have things changed? I mean, frankly, you have 2 decades to be able to compare against. But like, what's been changing?
Well, I think if I think about it a little bit closer, the changes, or the biggest change, is truly the pace of production from engineering, testing, manufacturing to real operations has really accelerated in ways that I don't think we could have even thought about 5-10 years ago, if you look at the pace of changes today. And from an electrification perspective, on the electronic side, certainly the complexity of systems and mechatronic systems and the software that goes on top, and the collaboration between the different groups that are unfortunately still under a lot of siloed kind of perspective of their world is really what we've seen where the most changes are occurring or have occurred in the last 5-10 years or so. If that makes sense.
So what, and when you talk about complexity, are you talking about like, more sensors, more functions? Are you talking about miniaturization, all of the above? Like, what's becoming more complex?
Well, certainly, I mean, the miniaturization and the complex merging of mechanical and electrical systems, mechatronics in general, and the harnessing of all these components on the hardware side certainly has seen a lot of transformations, become a lot more complex. But to be honest, the software components that are overlaid, and now we're talking about not just the onboarding software on these different electronics components, but AI models that are running on top of the electronics, and the purpose and the revisioning and the kind of self kind of learning that happens on top and that's really the traceability that has evolved and made this entire end-to-end kind of venture very complex.
So sorry, just to make sure that I understand and our audience understands. So you're saying that because there's other pieces, but one piece in particular is because there's now more and more products where AI is running on the edge as part of the product, that's certainly making the products themselves more complex. How does that tie into, you mentioned traceability, how does that tie into traceability? And frankly, how does that tie into the simulation kind of software that Maya is making?
Well, so when you think of the engineering aspect of developing those hardware that will then host those software and AI modules on top,
yep,
that traceability of which version of each of these components, there's the hardware level, the firmware level, the software that reside on top, and then the AI models on top. Each of those have revisions and their own life cycle. So the traceability of what is actually running on the edge is made a ton more complex. From a simulation perspective, right, we can simulate the heat transfer and the true reinforcement learning system level engineering of the systems that are running on the electronic side. So that all kind of combines together. But in the end, what results on after the manufacturing is done with is a product that can now still continue to evolve after engineering and manufacturing, which is kind of new and more complex, and kind of have the engineering and manufacturing folks have to think differently, because it's no longer we're going to produce this product and that's it, we're done. No, we're going to have to now build a new business model where we literally keep track of the telemetry on those items that are out the door to feed back into our engineering and manufacturing and make sure we continuously improve and keep trace of these end-to-end processes, which is a lot more complex.
And which piece of this AI like is Maya, like you VP of AI, like which piece is it that you're supporting the simulations that's needed for your customers to deploy AI at the edge and all of the kind of complexities around that? Or is there actual AI in like the software that Maya builds that enables these customers to be able to build these kind of AI applications?
There's really three areas of AI. So from the simulation model, when you have a very high fidelity engineering simulation model, we can create what we call AI-based reduce order model and virtual sensor that will augment what's out in production in real life. And I'll give you an example where, for instance, if you need to put a temperature sensor at the core of a turbine engine, well, clearly, physically, you cannot place it there. It's just not going to survive there. But if your reliability of the engine depends on that temperature, value, well, then we can build a reduce order model that, based on the rest of the telemetry that you will collect from that engine, you'll be able to trace back and calculate from the virtual sensor a value that will then be fed into a reliability engine that can run in real time. So
it's almost like a digital twin for a product.
Correct.
Is that right? Like
I'm correct.
Kind of making that up, but like
yes, no, I mean that's how let's say marketing would phrase it, like executable digital twin, as they call it. So yeah, that's really where we can use simulation models to convert it and reduce it to run in real time with the live product. So that's one aspect. The other aspect is simply to build actual AI reinforcement learning model to change controls. So for instance, if you have an electronic system level model for robotic arm manipulations of some sort, right? And you engineer all the controls around this and you build a simulation model of that electronics and the robotic arm that moves around. Well, you can have a reinforcement learning agent with rewards and business rules that will learn how it's ideally optimally behaving, and then putting that AI model in operation as a controller, a piece of the controller at the system level. So that's kind of an AI that's learned from a simulation environment to start with. And then of course it can continue to learn with the real environment, but it's not starting from scratch. So it doesn't have to break a ton of things in real life, right? It's actually pre-trained from the simulation environment in a virtual way, where nothing can get broken other than software fatal errors. But other than that, you move away and you implant it and it can continue to exist. So that's kind of how either our clients build those system level model themselves, simulation models based on our software, and then they build AI models themselves, right? They have the tools, or they solicit us from a service standpoint to deliver some of the AI models. That's kind of the more related to the simulation aspect of what Maya does. And then I'd say over the last 10 years, we've moved more into the operational side, where we build AI software as a service, where we don't have a solution. That's not our play in this world. We really offer our services to augment what is existing in manufacturing or operations with real-time telemetry, and other types of data sources.
So I think that's a good segue then to talking about like operationally how manufacturing has kind of changed over the last 2 decades. And certainly I know, about a decade ago, it was all about like GE was pushing Industry 4.0 and this whole concept that your supply chain was going to be smart and networked and you'd be able to make use of all of this data. And I think what we saw is some broken promises. We also saw something I think that did stick is like people understand their data is valuable, but it's really hard to use it, or it seems like people are struggling to figure out how to use it. And it seems like there's really few examples like a decade later of true like kind of that vision of networked systems in the operational side of manufacturing, like actually delivering on that value. Why do you think that is? And, what do you think is next for the space in terms of like, how can we overcome I guess some of it was maybe some pixie dust, like, damage that was done that burned a lot of people and then made it hard as a business that sells technically an Industry 4.0 product, makes it hard. It comes in and they assume it's all snake oil and there's no way it could possibly work because GE didn't work. So, but I'm just kind of curious as to what what is holding the industry back? What has held the industry back? Is it the same as what's holding it back now? Or is it like all holds are off and it's racing forward? What's your perspective?
Well, I think, referring back to snake oil, there is a little bit of people try to in day one to boil the ocean, right? Like they try to do it all and just
they want the moon and the stars, Remi. Not just one thing. I want all of it.
The next universe. Yeah, we can go.
And I want it to work with no examples, and I want it to work from every direction for any product I throw at it. Like,
no, you're hitting a really good point there in terms of the data was not there, or people being people think they have really good data, but it's often not the case, and not because of anybody's fault, but really because they haven't really looked at the data that they were collecting because they didn't need to, right? They were not running AI models at the end of the food chain until.
So they were just like dumping it in a database somewhere, but it was like dirty data.
That's it. Yeah.
Okay. So there's like dirty data lakes out there.
Yes.
And so that's why they haven't been able to, or folks haven't been able to like get a lot of value out of it because the lake's dirty.
Lake is dirty, and it's in multiple. We talked about multiple siloed systems.
Okay.
But, there's also the collaboration piece that didn't evolve at the same pace as the data collection piece that evolved over time.
Slower or faster?
Well, so the collaboration slower. Humans typically we're a bit slower than machines. I'm sorry to say, but we are. So in the end, it's not kind of difficult to see why the adoption, certainly in the early days of GE systems and other systems, and whatever company that tried initially in those big grand vision kind of approach, we've seen this fail time and time over again. The problem is not to think big, because eventually you don't want to accumulate technical debt by just running 100 POCs and never kind of get anything off the ground. But on the flip side, you want to start small with something that works, like Intrumental solution, by the way, right? You put it out and it starts
something
working.
that is vertically integrated, so you don't have to do a lot of integration to get value delivery at one point.
You get your small kind of effort that pays dividend right away, and then you keep growing, right? You keep scaling this up. So I think there are more and more cases today, like Intrumental solutions and other solutions, that really are starting small but adding value very quickly. And then people, and then the collaboration can be kickstarted and accelerated too, because now people start believing and understanding that, oh, this is enabling me, it's augmenting my pace of production, and my yield is increasing. Wow. and my quality is also, getting better and better over time. And I'm catching and finding those cause and effect problems on my manufacturing shop floor because it's the data, but it's also the solutions that are kind of a little bit more tailored to business use cases. So I think that's the combination of that evolution that we're seeing now. And certainly when we talk about data, we talked about dirty data, right? In industrial environment, it's like people should just assume. I'm tired of hearing like, oh, I have good data. It's like, no, you don't. If you have good data, you wouldn't need any of us on the planet to exist. And I'm sorry, but you do need us. And that you have to assume that your data is dirty until proven clean, right? and as you start, right, we use this now phrase, just assume your data is really dirty until proven clean. And that will allow you to build the right process and engineer the data pipelines that really will feed the AI models, the machine vision models, and everything else. And these will now reliably put out successful results and predictions, because what you're feeding it is actually been trained on those same pipelines, and those pipelines have safeguards. If there are outliers that come in, or the process changes, or the raw material changes, or something else changes in manufacturing that happens every hour, then you're not going to be caught off guard. The AI model will simply not produce those weird bad predictions and reduce its impact on the company. So anyway,
let's say there's someone who is dialed in and they have a data lake of some kind. They're collecting some data. Let's say they're on board with this concept that their data is probably pretty dirty, because that's this kind of the status quo. Like, what's your recommendation? Like, what should they tactically go do? Like, is cleaning up the data something that someone can buy, like software to help them do that, or services to help them do that? Or does it have to be cleaned up at the source? Like, every single source needs to be cleaned? And what's your tactical recommendation for how to go, like, be able to use that data? Should they throw out everything they have?
No, clearly not. But what really needs to drive the data cleaning process is the business use case, and where you want to use that data, and which portion of that data lake or data lakes that you need to source the data from. That will dictate how much data cleaning you need to do. And yeah, there are software solutions that do some of it. We do it as a practice with services, because we're AI as a service. So we bring in common best practice of how to clean the data, how to recognize flat lines and recognize these high spikes and process changes and drifting sensors and all that, the rest of it. So very industrial and practical look at the data, if it's an industrial environment, manufacturing environment, is needed. And yeah, we just go through, identify that small subset, small chunk of data that you actually need to clean. And it's not really retroactively cleaning. It's figuring out where it was dirty and building the safeguards in your pipeline to avoid it being dirty in the future, right? I mean, you can always clean it virtually, artificially, as you train your AI model. So you don't need to have these 6 months of effort to go and clean a data lake like that. That's boiling the ocean again. Like, no, don't do that. Like, if it's going to be more than a few days or weeks of effort, just step back. think of what business value you're going to get, and if the value exceeds that, whatever few weeks or days of effort, then fine, you can maybe do a little bit more cleanup, but just don't launch into these huge cleaning techniques. That's not.
How do you have any practical advice for leaders who know that there's value in their data, but they're kind of being asked by their organization to prove that there's ROI, to either invest in tools or clean the data to be able to even see what's in there, versus kind of like infrastructure, like on this balance between like our data systems and data infrastructure? Is that infrastructure, or is it something that's like should be tied to an ROI? And like, how do you advise your customers to think about that? Like, what's your thought on that tension between like how your customers think about it, but how other leaders should think about it?
Right. Well, if you already have data lakes, you already have a part of that infrastructure in place, right? Whether it's the right one or the wrong one, it's a little bit immaterial in the sense that's what you got today. So maybe the infrastructure versus ROI piece becomes more of a, how do we leverage our existing infrastructure, whatever that infrastructure is, and to get to the value faster. And when we say value, let's identify, like, is it a visual quality defect, right? Let's bring Intrumental system to tackle this. And what's the shortest path to a first ROI with AI based that will leverage my data? And often, like, people, as you say, are data rich, but they're wisdom poor, right? They know there's wisdom in there. There are like golden nuggets, but to uncover them, then they kind of need to start small still. Not like use the infrastructure you have in place. Don't rebuild a full infrastructure. You may think big as to, okay, once I need to scale up, right? What infrastructure is needed? That discussion and at a higher level is important, strategic kind of discussion. But you don't need to invest into a whole new infrastructure just for the first use case. You might put a baseline infrastructure in place or use what you have, and then go from there. So it's less of a, I mean, the infrastructure, most companies today have some sort of an infrastructure to start. So yeah.
Some rely on, it depends
Yeah.
on the industry and the vertical. I think
Correct.
some have their own, some rely on their manufacturing partners to essentially hold the data for them and then
Right.
to request it like as needed, which has its own pros and cons.
Yes.
And so I guess, it can depend, but we're certainly seeing in our space, which historically has been more like that, where you relied on your manufacturing partners to mostly hold the data on your behalf as a developer of an electronic product. We primarily operate in electronic space. That we've seen that shifting. So we've seen, even over the last like 2-3 years, customers who didn't have any of their own data now have some data that they're starting to pull in. They're starting to either DIY these systems or, take some off the shelf pieces to try to put together. And so it's certainly becoming, people I think are realizing that there's value in the data. And so they're starting, at least in electronic space, they're just starting to get their hands on it. So there's perhaps other spaces that you're working in that are a little further along where they have the lake, but they've been pumping dirty data into the lake, whereas like, some of these folks are starting fresh. So it's like a lot easier to just keep the lake clean from the beginning if you're starting fresh. Maybe as like a last kind of question before we open it up to the audience, what practical tips do you have for leaders who are evaluating AI solutions for a variety of different things? It could be, similar to Maya products simulations, like digital twin of a product kind of stuff. And, there's like all the buzzwords that are flying around in those sales pitches. And there may be a bunch of different companies that sell, frankly, very different things, but they all sound kind of similar when you look at their websites. What advice do you have for leaders who are trying to make good decisions about stuff that's actually going to be beneficial and not just be, the snake oil we're all trying to avoid? Poor snakes. Save the snakes. Don't make oil.
No, don't make oil. Well, unfortunately, I mean, it's a tough nut to crack in the sense of, AI has attracted legitimately a lot of people. And so, you get a normal distribution in any system, right? So you have from terrible to great. And unfortunately, it is tough when even I look at, our potential competitors or partners, it's really tough to find the right fit, right? So it's not easy. What I can say is when you try to find the right partner in your journey, make sure you spend a good time to, I'm going to say, properly drill down into the practicality of what that partner has actually achieved and done in real life, and try and get concrete examples and not just beautiful PowerPoint slide with icons, which we all love and we got accustomed to, unfortunately. But we need to yeah, people need to simply focus on the practicality and the examples, right? So if there's industrial use cases that you see in electronics, and we've done, lithium car batteries manufacturing and all sorts of other things, these are real examples that we can showcase and kind of bring to those customers. And I wouldn't want us to go into legal departments for marketing in terms of AI services, right? People say, oh, data is data. Well, no, data is not just data. You need the physics-based understanding in engineering and industrial manufacturing to be able to make a difference. And if you don't have that background and that history, well, I'm sorry, that's why you're gonna see a lot of failures in the newspapers for, based on these. So yeah, I would say
why some of these highly generalized platforms that are like, oh, we're AI for everything, why they're not really used by companies that are actually manufacturing things. Because there's lots of great products out there for like logging, like Splunk, or like looking at dashboards like Tableau. These are not tools that were developed for manufacturing space. Can they be adapted to like do some stuff that's of value for manufacturing? Yes. And there are companies that have like, fit the square peg in the round hole.
Yeah.
But like, you're not going to get out of the box, your dashboard that's got your Paretos on it and things like that. I think for a long time, we aren't Looker customers, but in the earlier days of Looker, like some of our customers were Looker customers, and Looker like didn't do histograms very well. And like in manufacturing, it's essentially like run charts and histograms. That's like all we care about.
Yeah.
Particularly Pareto versions of histograms.
Yes.
This is like a special kind. And so I think there's benefit to having that expertise in the space and the use cases that are really aligned with what customers' problems really are. And so I would certainly agree with you that finding vendors who seem to like really get the problems that you're trying to solve and maybe have solved those exact problems before, or if not exactly that, like they've solved sufficiently similar problems for other folks that are like, okay, this is like only a small leap of faith versus like you've only sold into retail businesses before, and now you want to come and help me make lithium-ion batteries. I think quite different. So those generalized solutions seem pretty challenging or pretty challenged. It doesn't mean that they can't work. It's just I haven't seen customers really kind of slurping those up.
No, and it takes this expression, a month of Sundays to get them, to get to any useful results in business use case.
Yeah, I think the devil's in the details for integration. So like another good kind of tip is likely around what does it actually take to get up and running? And I think that many people have a good, healthy sense of skepticism on that. We experience that in our own sales process. And
we do as well.
I think it's good that customers bring that skepticism, because that is where it gets you, is like, what is integration going to cost and how long is it going to take? And then, what is it really? Is it going to work then? Or is that just to get to something that we can start tuning? All of those are really important questions to know the answers to. I'll admit that for us, it's all like, those are all very fast, but our customers still don't believe it because, the wealth of experiences is alternatives to that narrative. So I think asking, those are all the right questions to ask, and good tactics for folks who are evaluating these kinds of solutions.
Yeah. Well, and you just hit it on the head. And, when you look at timelines and, asking just roughly how much time do you think this specific thing would take? And if you get a blank stare or, deer in the headlights kind of a view, like, okay, well, maybe that's not the right partner to build it.
Yeah, absolutely. Well, I think we'll wrap it up there. Thanks everybody for joining us this week on Change Notice, and keep your eye out for upcoming episodes. We have some great stuff in store on the calendar, so we'll be revealing those soon in the coming weeks.